Hello, my dear students. Myself, Devi Prasad Sir, welcomes to you all to this chemistry class. Today, we'll study about the electrolysis of molten or fused lead bromide, in which the electrolytic cell is used, that is, the silica crucible. The electrolyte is molten lead bromide. The electrode, cathode, is made up of iron or graphite, and the anode is made up of graphite. Both the electrodes are inert electrodes, that means they do not take part in the electrolytic reaction. The temperature is to be maintained above 380 degree centigrade, that is the melting point of lead bromide. The ions present in the electrolyte are lead ions and bromide ions. The reaction at the cathode, that is Pb2 plus 2 electrons, gives rise to Pb, and the product at the cathode is a spongy lead metal, and it is formed due to the reduction reaction taking place at the cathode. Now, the reaction at the anode, bromine ions, they lose electron and they form bromine atom. Two bromine atoms together, they combine to form a bromine molecule, that is Br2. Now, the product at the anode, reddish brown vapors of bromine vapors are formed. Now, the electrolysis of molten lead bromide involves oxidation as well as reduction reaction. Therefore, it is called as a redox reaction. My dear students, the electrolytic cell is made up of silica and the crucible is heated slowly from outside. It is because the crucible is made up of silica. It is non-reactive and it can withstand high temperature and is almost a non-conductor of electricity. Solid lead bromide is a non-conductor of electric current since its ions are not free to move, but they are held together by an electrostatic force of attraction. The ions become free when lead bromide is in the fused or molten state. Hence, the crucible is heated to maintain the lead bromide in its molten state. The metallic lead ions are discharged at the cathode as lead metal and bromine is liberated at the anode. The cathode is an electron donor and metallic lead ions need electrons to discharge at the cathode as neutral lead atoms or metallic lead. Now, hence, lead ions gain electrons to form metallic lead atoms. Hence, the lead atoms are then deposited as a silvery grey deposit around the cathode. Now, the bromine ions give up electrons, resulting in the formation of neutral bromine atoms. The neutral bromine atoms form bromine molecules by forming a covalent bond between them. The reddish brown vapors of bromine are hence seen at the anode when the molecules of bromine escape from the molten lead bromide and evolves as bromine vapors. Now, the cathode and anode are inert in nature and generally they are made up of graphite, as it is mentioned. Now, the electrodes are inert since they should not take part in the electrolytic reaction. Otherwise, they would prevent the discharge of the respective ions. A graphite anode is preferred to other inert electrodes such as platinum since graphite is unaffected by the reactive bromine vapors. Now proceeding towards the electrolysis of acidified water. In this case, the glass voltammeter is used as the electrolytic cell. Now, acidified water is used as the electrolyte. It is acidified with dilute sulfuric acid, that is dilute H2SO4. The electrodes, both the cathode and the anode, both are made up of platinum foil, and these two platinum foils are also inert electrodes. Now, the temperature is ordinary temperature. Ions present in the electrolytic solution is H plus ions, sulfate ions and hydroxyl ions, that is H plus, SO4 minus minus and OH minus. the reaction at the cathode, H plus 1 electron gives rise to H, and 2H plus 2H gives rise to 2 hydrogen molecules. The product at the cathode is 2 volumes of hydrogen gas, and the reaction at the anode, OH minus, it loses 1 electron to form OH, which is multiplied by 4, that is 4 molecules of OH. Then 4 times of OH gives rise to 2 water plus O2. Then the product at the anode is 1 volume of oxygen gas. The electrolysis of acidified water involves both oxidation as well as reduction. Therefore, it is an example of reduction reaction. Now, my dear students, the water is a non-electrolyte. In order to make it a good conductor of electricity, dilute sulfuric acid is preferred to dilute nitric acid, since dilute sulfuric acid is a non-volatile acid, whereas dilute nitric acid is a volatile acid, and the nitrate ions may tend to interfere with the electrolytic reaction. My dear students, I hope that you understood this part of electrolysis. In my next part, I will explain you about the electrolysis of aqueous copper sulfate. Thank you for watching and learning from this video.